Good morning, students. This is Dr. Bridges. I'd like to talk to you for a few more minutes about linear programming. I know you're working on linear programming now, and so you probably have looked at a small slide presentation that I made with some audio that was overlaid into the slide presentation. I want to go a little further now and go into an actual problem, but I wanted to follow along with video so you could see some of the things that I'm talking about, and I could refer to them as this is a little bit more of a one-on-one instructional period. And so if you could, it would be very helpful if you pull out your book now, go to pages 834 and 835. Those are the pages that contain the example, which is example 1 in your text in chapter 19 that I would like to refer to. So I'm going to pause the video now here for a second and show you that particular slide. So you might want to pause the video yourself, okay, and then restart it once you've opened your book to 834 and 835. Okay, students, now that you've got your book open to page 3, or 834 and 835, and you've taken a look at the problem again, hopefully, you recognize that in this problem there are 3 products. Now, the objective of this problem is to make these products in such a mix such that we maximize our profit. And of course, there's profit associated with making each one of these particular products. When we take the profits with the quantities that we're making of each product and we put them together, that forms our maximization function, or objective function that we want to maximize. So we go back and we look at this and we say this is what we want to maximize. But when we look at all the other things in the problem, the real world things that affect us, they are the constraints. In this case, we have labor restricting us to do no more than 250 hours. So no matter what combination we make, we cannot exceed a labor of 250 hours. And you can see from the first equation on labor that the coefficients describe with each one of the variables or decision variables how many hours are used to make one of those particular products. Then we go on to labor, material. And in material, we've only got 100 pounds to use. So there we have a certain amount of pounds of material that go into each and every product, and we express that in equation form as well. And of course, when we add all the different units together with how many pounds each one uses, that has to be less than 100. The third constraint there is on product number 1, where we have to make at least 10 of those units of product 1. So this is kind of very typical of what we find in the real world, where things are not clear-cut. We can't make exactly what we want across the board in order to maximize our profit. We have some constraints upon us. And that's what the linear programming problem allows us to do. It allows us to look at those constraints and to provide a product mix that's going to provide us an optimal solution where we can either maximize our profit, and in some problems we would be minimizing our cost, but in this one we're maximizing our profit. You'll notice at the bottom there's this one equation called a non-negativity equation, where we express each one of our variables, x1, x2, and x3. As you know, we can't unmake these items, so they all have to be in quantities of 0 or positive. So x1, 2, and 3 are all more than or equal to 0. Now it's important that we state that, but it really doesn't come into the solution of the problem when we mathematically try to solve it. We try to use the objective function and each one of the constraints. Now in your homework problem, you're going to be looking at a very similar problem. You're told various resources. I think you have shoes, raisins, caramels, chocolates, and they all come in some in combinations and some alone in their own box. Read the problem well. Identify what your decision variables are. That is, what and how many of each box of different types must I make? I want to maximize the profit. I know how much each one will make me when I sell it, each different type of box. And so that's going to form our objective function. But we do have constraints. There's only so many of each one of these resources available. And in the different boxes, these items go in different quantities. So analyze that very carefully. That's the toughest part of this problem. But look at that carefully and determine how much of each resource goes into each one of the different boxes. Then, of course, make sure you've read the problem, you've looked at it from every angle, and you've identified all the constraints. Make sure you have all the constraints in the problem. Thus, you should have pretty well formulated this LP problem of having a objective function that you're going to maximize and a number of constraints that you have to take into account for in this maximization. I hope you enjoy this exercise. You've probably never done anything like this before, but it does let you know that there are ways for us to maximize our profits or minimize our costs associated with making different types of products and or services that have a mix of different inputs. Good luck.